So we have some basic understanding of what the black hole should look like. There are some predictions from general relativity, for instance. And we also expect there a disk of gas, an accretion disk around this black hole. It has some background illumination by that hot gas. So the hot gas provides this background illumination, and in front of it we should really literally see the shadow which is carved out from the hot background light. But because it's such a strong gravitating body, it's not just a normal round shadow as you would expect it from some normal object, but you actually, as I tried to say, you have some photons having some funny path around the black hole, even from the back side, that you would otherwise not see. And that produces this very interesting shape of the black hole image. I don't know if you have seen the movie Interstellar. There's some nice rendering of a very high resolution image of what it may look like. Our image will not be that high resolution. It will be a bit disappointing, I think, if you think that's what you're going to see. But it will hopefully still show that there's basic features of being bright on one side, dark on the other, with some halo around it. That would then indicate that there is an event horizon. I would like to find a pulsar around the black hole, because if the pulsar orbits the black hole at the same time, in further distance than the gas, but I would nevertheless be able to sort of measure the spin orientation of the black hole by looking at the orbit of the pulsar. And so if I found a pulsar, I can tell Luciano, who's our modeler, how the image should look like. And then we can give it to the observers for doing the image, and then they compare the expectation with what we actually observe. And so we can actually do more than just take an image. I think we try to understand the physics behind it and therefore test really the predictions of how black holes should look like. Personally, I would find it much more exciting if we find a discrepancy, because that means that so far the theory is only an approximation to something truer or even more valid underneath. It's like Newtonian gravity, where people have thought Newton's gravity is valid for hundreds of years, and then we found deviations, for instance, in the orbit of Mercury. So it's a very similar analogy. So by falsifying the theory, you learn much more sometimes than by actually confirming it all the time. So I think that would be much more exciting.